Okay, so here I'll just go on ahead and tell you the eigenvalues are plus and minus 3i, plus or minus the square root of 3i, or you could just write it as lambda 1 is equal to the square root of 3i, lambda 2 is equal to minus the square root of 3i. Okay, so in a case like this, you know that the general solution is going to be some linear combination of these trigonometric cosine sine vectors. It's going to be cosine of the square root of 3t, sine of the square root of 3t, some sort of linear combination of vectors like that with no exponential term. Okay, but what I want you to know is that when the eigenvalues are purely imaginary, in other words, they're complex where the real part is 0, then the trajectories, the solution trajectories, or the solution curves in the phase plane are going to be ellipses. Okay, so let me just write this down here. When the eigenvalues are imaginary, that is, the real part is equal to 0. When the real eigenvalues are imaginary, then you have ellipses. Okay, so we know we have ellipses, and so now we want to know, are the ellipses going to be going in the clockwise direction or counterclockwise direction? And we want to sort of get an idea of what the orientation is. And to do that, we're going to basically, to answer both of those questions, we're going to do one thing. We're going to consider this point right here where x1 is equal to 1 and x2 is equal to 0. And we're going to say for the curve that passes through this point, what is the tangent vector going to be? So in other words, we have some solution. X of t is equal to some vector function. We want to find what the derivative of x prime is. That's going to tell us what the tangent vector is, and that's going to tell us the direction of the curve going through this point. Okay, now one way to do that is to find a solution to the differential equation, find the one that goes through 1, 0, and then take the derivative of that. But the easier thing is to use the fact that we know that x1 prime, x2 prime is equal. We know that x1 prime, x2 prime is equal to this matrix times x1, x2. So in other words, if I have some solution, x1 of t, x2 of t, then its derivative at the point 1, 0 is just equal to this matrix 1 minus 4, 1 minus 1 times 1, 0, and this is equal to 1, 1. And so I know that the solution curve, when it passes through this point, is going in this direction. And so this tells me that the ellipse is going to look something like this. Okay, so I know it's going to be oriented this way, and it's going to be going in the counterclockwise direction. Okay, and then all the other ellipses are going to be kind of like this as well, all going in the counterclockwise direction. Okay, and this is all the level of detail that you're going to need to be able to do for the exam. Okay, I want you to know two things. One, if the eigenvalues are imaginary, we're going to have ellipses. Two, when we're sketching the solution curves, we evaluate the matrix. We do the matrix times 1, 0. That's going to give us the tangent vector through this, the tangent vector of the curve going through the point 1, 0, and that's going to indicate the orientation of the ellipse and also the direction that the ellipse is going in, or the direction, whether it's counterclockwise or clockwise.